reasonable human can remember at this point. It's a local web tech meetup for Brighton and Hove, and yeah, I have a clicker. Thank you for reminding me. Tonight we have a fantastic talk, but before I hand over, I've just got a couple of bits of admin. So today's agenda: the introduction, the talk, Q&A, closing remarks. I think the closing remarks are going to be me, so I'm going to have to come up with something between now and 8:50. Okay. Most importantly, perhaps, we have a code of conduct, which if you go to that URL that is up there, will give you the ins and outs of it. But the TLDR is just be kind, be nice to each other. If you feel uncomfortable at all, come and talk to me, Jake, if you could raise your hand. Exactly. Charlie, if you don't mind as well, being someone as well, that would be great. We want everyone to feel very welcome and included here. We are in Runway East, and isn't it fantastic? And to say a big, I want to say a big thanks, to give you a little bit of introduction to Runway East. I'm just going to hand over to Viva quickly, so I'm going to run over here. There you go.
Hi everyone, thank you for being here. So Runway East, as you probably know, is a co-working space, and if you are interested in working in a co-working space, this is a great place to work. So if you'd like to have a tour after the event, you can come up to me, or if you have any questions, just ask after the event and hopefully I can answer them.
Fantastic. Thanks very much, Viva. What Viva is too humble to say is that they've also bought all the pieces that you've been chowing down on this evening. So thank you so much for that. It's very kind of you. Thank you. We also are in the presence of the wonderful Silicon Brighton, and particularly Charlie Hula, who I'm going to hand over the mic to as well. Here you go, Charlie.
Thank you very much, Ali. Appreciate it very much. Hello, guys. Nice to see you all. My name's Charlie, and I have the pleasure of working in events and community engagement for Silicon Brighton. As you may know, we like to think of ourselves as the host of Brighton and Hove's tech sector. We support over 30 different meetup groups across the tech and digital scene across the city. All of the events that we run are free to join, available to people at all levels, and hybrid. So obviously all of you are here in the room with us tonight, but we're also running a live stream. Hello, everybody who's watching on YouTube. For anybody who can't make it in the room, and for you to be able to watch the event back at your leisure when we've finished. None of the work that we do would be possible without the help of our fantastic sponsors, all of whom you can see here. And if there's a company who you know who might be interested in supporting us, who you can't see on this list, maybe point them in our direction. We would appreciate it very much. None of the work that we do as well would be possible without a small army of people who help us get everything done, from meetup organizers to speakers to volunteers. And if you have any interest in getting involved in a large capacity to what you're doing now, maybe you want to come and speak at an event or play a larger role in helping out with a group, please bring yourself forward, come and chat with myself or my colleague Maureen, who are both here tonight, as we would love to get as many people involved with what we do as possible. This is our list of values, which we look to uphold at all the events that we do, which I believe Cite Your Influences was something we put together off the back of Async's code of conduct. So thank you guys for the influence on that one. If you feel at any point similarly that these aren't being upheld in anything that you see us do, please let us know, because we will look to rectify that as quickly as possible. We're also on socials, on Instagram, LinkedIn, Twitter /X, and TikTok at Silicon Brighton, where you can see all the pen content that Maureen puts out, and you can join the Async Slack community at this QR code if you haven't done already. And if you haven't done already, what are you doing with your life? Get yourself on there. It's brilliant. That's everything from me. Thank you very much, and enjoy the evening.
Fantastic. Thanks very much, Charlie. Nice one. So a wonderful amount of humility going on this evening. Charlie and Silicon Brighton also paid for the drinks that you've been kindly imbibing. So thank you so much. And just another note that throughout this long and somewhat illustrious career of Async, we've been in a variety of venues. We've mostly been on our own. In this last year or so, we've had the joy of being in Runway East, but Silicon Brighton as well have literally put a fire under us, and it is so much easier for everyone involved having Silicon Brighton's wonderful support. So yeah, I'm tremendously grateful, and I will never stop saying it. But now it is time for us to introduce our wonderful speaker. So tonight we have Chetan. So I'm going to hand you over. Please give him a big round of applause.
Thanks, Ali. Okay, so this is the first time I've given this talk about something we built relatively recently. We'll see how it goes. So I'm going to talk about real-time collaboration with Redux. So yeah, we'll get into what that means. So firstly, who am I? Well, firstly, I wanted an excuse to use that really cool illustration of me. We had some done for the whole team, and it's really great. We have this amazing illustrator that does a lot of our artwork. Anyway, so I'm in charge of the software at Clockwork Dog. I've been there sort of for 5 years. I guess I've been freelancing for a lot of that. And then eventually I sort of spent so long freelancing for them that they just asked me if I wanted a job. So I really like working at the intersection of hardware and software. So I'm very much a software focused person, but anything that's got hardware involved, I just always find it more interesting, and it's just always more engaging. And on that note, we recently started a meetup called Breaking Breadboards. Talk to Nick Hill if you want to learn more about it, or myself, obviously. So it's a new meetup in Brighton. We've done one so far, and the idea is to kind of get anyone that's interested in Arduinos, Raspberry Pis, electronics, kind of like the hardware, software kind of like world. Yeah, so the next one's coming up in July, the 17th. Thank you, Charlie. So yeah, keep an eye out on Meetup and search for us. You can either go to breakingbreadboards.com, that has a link to the Meetup, or you'll find us on meetup.com. Okay, so I mentioned COGS. So what is it? I think that's a fairly good place to start. So I spend most of my time working on COGS and on the software side of COGS, but actually COGS is a bunch of hardware and a bunch of software that communicates together. So the hardware is designed for connecting sensors and lights and servos, like anything in the physical world. And the software is designed for controlling it and for sensing that kind of stuff. So COGS is designed for escape rooms, immersive theater, kind of large scale, kind of theatrical kind of productions. That's what it's designed for. So it's got to be super reliable and, you know, always work. But on the software side, we've tried to keep it really easy to use and keep adding more features to it all the time. So we try and keep it sort of relatively low code as well. So I'll try and show you a bit about what it is. So here's a little screenshot of COGS, the software. So COGS, you define a whole bunch of inputs and outputs under your channels, and then you create behaviors, which if you've ever used if this then that, it's a kind of similar model. So you have a when, and you'll have a bunch of conditions on there, and then you'll say do, and you can have a list of actions. And basically you can build up some pretty complex logic using just that very simple model. So yeah, we started creating this, well, I guess before I was even involved in the company. They started creating this and sort of installing it in various places, but it was kind of very like hard coded to work in for one thing. But now obviously it's a lot more configurable and it's sort of very much drag and drop. So yeah, it's great. But we've been getting, you know, so as a company, so I work for Clockwork Dog, that's the name of the company. And we have been working on more and more stuff. So people come to us and say, okay, I want to put COGS in my escape room. I want to put COGS in my theater show. How do I do it? Or sometimes they say, we have all this stuff. Can you just come and do it for us? Because we don't know how to do it. So it starts to get pretty tricky. So I found, for example, when I went and worked on the Saw immersive experience in London, which was running up until last year. So it's a huge production. And it's sort of all based around Saw, the horror film. And there's various things where you'll kind of get locked in and really apparently awful things will happen to you. But obviously no one dies, basically. There's no real blood, no one dies. It's fine. but it was one of the biggest things we've ever worked on. And the more the more and more stuff we put into it, the more complex it was for our team and the other teams working with us to work on it. So, we'd have 6 or 7 people jumping around trying to work on the same thing. And so we'd have our little piece of software, COGS, which is just a desktop app that's installed on a machine somewhere. So our solution to that was basically, if we want lots of people to work on that thing, then we'll have VNC installed that allows them to kind of get a remote desktop view of it. And then basically you just have people shouting over a wall being like, can I use it now? Can I use it now? And then you just sort of like, people fighting for the mouse, basically. It's a complete pain. And the other thing we found is that for these bigger and bigger experiences, it was just getting really slow. So we started having to look at like what was making it really slow, like why was that happening? And so we'll get into that later. So how is COGS, the software, built? Well, we use Electron. Hands up if you've heard of Electron. Pretty much everyone. We've got a few people who haven't. So I'll come back to what Electron is, but the important thing is it's basically a web browser. It's a glorified web browser. It allows you to do kind of browsery stuff. We write all the code in TypeScript, which gets compiled to JavaScript. That JavaScript runs in Electron. And then the 2 JavaScript libraries that we use, it's pretty standard across a lot of like web apps, are Redux and React. So Redux we use for storing all the data, and React we use for kind of rendering the UI. So we'll go a bit more into those in a moment. So how does it work? So what we had is like, this is the way COGS used to work, basically. We'll kind of come back to like how things have changed. But basically, Electron allows you to open a browser window. So browser window is an API that basically says, I want to open a window that is basically a Chrome, like a Chromium window. But it doesn't have a URL bar or whatever. It just opens like a window, so it looks like an app that belongs there. And so and to make it feel like a native app, we have the entire app just running as kind of essentially just one big website in that window. So all the logic in COGS is a Redux action that goes through Redux, and React Redux is used to kind of take the data out of Redux and render it as a React UI. We'll go a bit more again into that in a moment. So how does Electron work? Basically, it's Chromium. So if you know Google Chrome, it's basically it's the open source thing that Google Chrome is built on. Chromium is kind of Google Chrome without the Google bits. And it has a Node.js API for opening a window. So that window has a few superpowers. So it can basically use some or all of the features from Node.js. So Node.js, it looks like JavaScript, but actually it can access the network. It can access the file system. It can access kind of all the stuff on the machine. But it can also access all the normal browser stuff and display a website, essentially. So you can just seamlessly use them both. There's kind of the whole thing's just exposed to you at the same time. But the kind of one downside is that the whole thing's sort of single-threaded. It's like it makes the programming of it easier, but it means everything's kind of happening all in one thread. So it's kind of hard to like offload computation. So Redux. Who's heard of Redux? Who's familiar with Redux? Yeah, kind of a bit more than half, I would say. Okay, so Redux is what's called a sort of state management like store. So we'll go through a few of the concepts of what Redux is used for. So the Redux is called the store essentially. So you'll have like a store variable, which is a sort of handle to the Redux store. And a Redux store will have an initial state. It will have some actions that are basically just data objects that are handled by a reducer. The reducer is basically just a function that will look at that action and change something on that state. It will basically give you back a whole new state, and then you end up with a new state, and then everything can just look at the new state rather than the old state. So interestingly, you can actually split this up into lots of different slices, and then you can combine them all together. So you can have something a bit more complicated. And you can also have middlewares, which can perform side effects. So the middlewares, you don't need to worry about for the moment, but middlewares can basically say like, okay, I saw this action happen, so I'm going to send something out to the network. I'm going to write a file on disk, that kind of thing. In the world of Node.js, obviously, because we're in a world where we can kind of do both. We've got access to the web and we've got access to Node.js. So I really like Redux. It's kind of very predictable. It's very easy to debug. You can kind of look at the tools and see exactly what's happened, what's changed. The dev tools for it are really great. So here's an example of what a Redux store would look like. So you start with an initial state. Usually that's some sort of big JavaScript object. You'll have an action. The action is run through all the reducers. The reducers will give you back a new state. You have another action that will give you a new state. You have another action that will give you a new state. So it's a relatively simple model of like how things change within an environment. And so in COGS, actually, we just have everything in Redux. Everything's a Redux action. And it makes kind of dealing with complexity a lot simpler. So why was it slow? We started looking at like, why does the app get really slow once we start adding more and more stuff? So once we noticed that once the user interface got really complicated. So we have what we call dashboards. So they can have like little lights or switches for, controlling physical lights in the room, for controlling smoke machines, for controlling like whether a door is open or not. So the more we have of those, and in something like SOAR, we had hundreds and hundreds and hundreds of those. If we're rendering all of that as kind of HTML on a page, and React is going, okay, now I might need to re-render a whole load of it, then actually the React re-rendering is possibly taking a long time. So generally, JavaScript is pretty fast, right? So you're generally running on V8. V8 is really, really speedy. So if you're just manipulating data, it's really, really, really fast. But as soon as you're interacting with the page, with HTML elements, with the DOM, that's when it starts to get really slow, especially. And things like React are essentially like looking at what was there, trying to do a comparison and all these sorts of things. So it does tend to get a bit slower. So we realized like actually it was the UI rendering that was slowing it down. So the more complex it got, the less we could do these Redux operations. And those Redux operations, remember, have those side effects that are calling out to all the hardware. So it means we can just do a lot less hardware control just because our user interface looks a bit fancier. And the worst thing is say you've done something wrong in the UI, you've written something that like, I don't know, so some of your UI code is a bit dodgy, and so there's a crash in your front end. Well, that means actually the whole process has crashed, right? We can't process any more input or output for the hardware, and that means the whole thing is dead. So it's not great. So we had this idea of like, well, what if we could split it up? So what if the thing that was actually talking to the hardware only had to deal with all the Redux operations, and then we can have something else that's responsible for the user interface? So the idea was essentially, let's have another browser window. So we have one that can talk to, that's a Node.js kind of enabled browser window that can talk to the network and hardware and all that kind of stuff. And then we have another one that has the user interface in it. So what if we could separate the two? But then we were like, well, how does the user interface know what to show? So we kind of started toying with this idea of saying, well, what if we could clone all of the data from one side into the other side? So yes, it would still be doing the same work in Redux in the browser, but it sort of doesn't matter because that's all happening in a separate process. That's not going to slow down all the other stuff that's talking to the hardware. And if we can, we want to try and keep all of our React code without having to sort of change anything. Just sort of move it all to a new window and everything will just work. So we don't have to kind of rebuild everything. So this was the kind of scheme we came up with. So on the left is our one of our kind of windows, our sort of invisible window. So we've kind of said, okay, that one is now going to be invisible, the one that you could see before, and it doesn't render anything as a user interface. It just runs Redux and does nothing else. But we also were adding a middleware that can talk to the browser window, which is now our new window. And that one's going to basically keep the browser window up in sync. So they're going to talk backwards and forwards to make a kind of perfectly in sync store. So yeah, how do they do it? Well, the more we looked at it, the more WebSockets look like the right option. So WebSockets are great because they're all based on TCP. I think someone's trying to get in, by the way. Okay. So WebSockets are based on TCP. So TCP means that because it's built on top of TCP, everything's guaranteed to be in order, and you're guaranteed to get all the updates, as opposed to something like UDP where it's lossy, you might lose some stuff. So unless your connection fails entirely, you know that everything you're getting is kind of, all happening in the right order and you haven't missed anything. And I decided to use Socket.io as like a layer on top of WebSockets, mostly just because it kind of gives you a nice TypeScript API. And it will tell you like something's been disconnected. It sort of does all this stuff behind the scenes to kind of keep communicating backwards and forwards and polling and just say, hey, are we still connected? It kind of deals with all that for you. And it has a few optimizations for like loading really quickly over HTTP and stuff like that, but it's a bit of a detail. And the cool thing is with this architecture, so if we go back here, so we've got the Node.js server is just going to run, it's going to run a web server, like a normal web server. So WebSockets are built into the browser. Socket.io is a library that can just run in the browser. So our other window is just a normal browser window. But it means that any browser window can also connect to the same server and see the same thing. And then once you can do that, I mean, that web server is just running on a port. So we expose that port to the world, then anyone in the world can see the same thing. So the problem with moving to a world like this is we're kind of moving to this kind of client-server model like a lot of apps. And we want it to really feel like a native app. I think a lot of modern apps kind of have some idea of how this works, but I'll kind of talk about how we implemented it. So we're going to talk about how we kind of do any updates kind of locally first, also known as kind of optimistic updates. And then we'll, because we basically just don't want to have to wait for that communication from the web server and back again. Remember, this was all running in a single thread before, and now we're having to talk to a web server. Even if it's on the same machine, it's kind of having to cross-process, communicate some stuff, serialize it, send it back again, parse it, and then do something with it. So it's definitely going to feel less performant. So we're going to try and predict the future. That's the way I'm going to look at it anyway. So this is the old way Redux runs. It's pretty boring. It's just a straight old line. But now we can be a bit smarter. We have a copy of the Redux state. So in COGS, so on the server, we have the Redux state. We're going to make a complete copy of that state. We'll start with that state and go, right, we're going to make a whole new Redux copy. Then if there's an action that happens on the server, we'll send that same action to the browser. The browser will apply that action to its Redux state, and they'll both be in exactly the same state because they started with the same state, they've got the same action, they've got the same code in the reducers, they'll do the same thing. Now, what happens if we have an action on the browser? Well, because we want it to feel like a native app, what we'll do is we'll say, okay, we're going to run that action on the browser directly. But we'll also send that action to the server, and we'll tell the server, hey, can you just run this action for us? The server will then go, okay, I'll run that action and also confirm back to the browser that it has run that action. And then the server's going to go, okay, great. So now I can just sort of roll back what I just did and apply that same action as it came from the server, because I know that's exactly the one that the server did, and then move to this whole new state. So then we can just get rid of that old draft state, and then any more actions that come in, we just apply those and we just keep on moving. I hope that's making sense. Okay, so a quick reminder. So we have two separate windows. I'm going to send an initial state over. Any actions that come from the server, we're going to send over to the browser. And then from the browser, if there's any draft actions, if there are any actions coming from the browser, we send them to the server as a draft. The server sends them back as an action, as like the sort of source of truth action. All right, so we're going to look at a little bit of code. Don't worry if you don't follow everything. I'm just going to try and give you a kind of overview of like roughly how it works. So firstly, generally you will use this kind of make store API to make a Redux store. And on the server side, we're adding a middleware. So the new bit is this middleware that wasn't there before. So that's called the create remote UI server middleware. And that's the thing that's going to start a web server and show and kind of allow the browser to connect to it. Interestingly, when something connects and when something disconnects, we can dispatch another action. So we can basically dispatch another action to the store, which the reducers can deal with. So we can actually record that something's connected or something's disconnected. So the first thing, when something connects, the first thing that connection will see, and the first thing all connections will see, is that something has connected. And you can kind of, display that on your UI if you want to. So on the server, so yeah, so inside that middleware, we'll start our socket IO server, which is again just a WebSocket server with some like nice little APIs on top. And we can say when a connection comes in, send an init message with the entire state from Redux. So take everything that's in there and send it over to the browser. And then if we get anything from the browser, if we get any actions on this dispatch message, we are going to dispatch those actions on the server. All right, I hope this is making sense. Then on the client, we construct a URL to that server. In this case, we're actually just running all of our web content on the same server, so it's actually pretty easy to construct a URL. And then what we're going to do is try and construct that. So we're going to construct that new Redux store that's a complete clone. So what we'll do is say, okay, we're going to make that same store, and the state we're going to pass into it, the initial state of that store, is the one that we just got from the server, when we just got this init message from the server. There's a few nice little things we've added in here. So this UI connection provider thing is like, if you're familiar with providers in React, got a few nods, yeah. Basically what that does is just allow that connection ID to be accessible from anywhere in your kind of React UI, which means, you know, if something needs to know which connection am I, it can kind of ask that provider. So yeah, so we've created a store, and we've made that store available to everywhere in React Redux. Okay, so now we're going to go to, let's try and work out how to implement this. So how do we do our kind of optimistic updates? How do we make that draft state? Again, on the client side, we're going to use an enhancer. So we haven't talked about enhancers yet, but in Redux, an enhancer is basically something that takes Redux store and adds stuff to it. And that stuff can be more state. It could be special methods. It could be more another reducer. It could kind of like change some of the reducers. It could add another middleware. It can kind of do anything. It's almost just a sort of wrapper function, really, that can kind of do whatever it wants. So in this one, we've got one that says, okay, if an action's dispatched here locally in the browser, then send it to the server. So that's the thing that's going to say, hey, server, some actions are done here. Can you deal with them, please? And tell everyone else that that's happened. And inside it, we're going to create an enhanced reducer. So again, we're running the exact same code that's running on the server side, but now we're going to wrap it in one extra thing. So the default case, now this is basically where we're looking into the future. So we're going to say, right, we're going to take that action. So any action that we've received, any action that we're dispatching, so any action that's happened, we're going to tag it. So we're going to tag it and say, like, this is something that came from a browser rather than an action that came from the server. And then we'll say, okay, we're going to run that locally, and we're going to add it to our list of drafts because we've sent that to the server, and at some point we'll get some sort of response that says that's been dealt with. And then we're just going to run it through our reducer just as normal. And so then when we get actions from the server, we're going to dispatch this magic new action type that we've created. And that's called remote UI action types. So we're just going to dispatch that in. So that's basically how we're going to know that we got something from the server, and that's going to get dispatched on top. And this is kind of the magic kind of looking into the future bit, right? And cleaning up. So what we're doing here is we're saying, right, we got some actions from the server. We're going to find the last clean state that we know we had. That was like our last source of truth that we have from the server. We know we've got the next one, and that must be the next action. So we're going to apply that on top and apply any others that we have on top of that. And then we will then, if there's anything else that's left that we haven't had a kind of confirmation for, we can kind of replay that on top. So we still can potentially have like a sort of a draft state that we're in. So anything that's happened locally, we will see that that's happened. And then when we eventually get a confirmation from the server, we'll kind of like clean up all those draft versions and then end up with a nice, with the source of truth from the server. And there's a little optimization that we added. So one thing I realized was like, so the way Redux works is as soon as you change the state, generally what you do is you say, okay, well, here's an entirely new state object. It's a sort of anti-pattern in Redux to take the set. In fact, a lot of stuff won't work properly if you just like mutate that data, if you just change some of the data in Redux. Instead, you go, here's a whole new object, and it's got a whole load of new stuff in it. So we can actually very quickly then say that, well, if our current state is the same as the last state, we don't really need to send it to the browser because it didn't do anything. So this kind of crops up when you might have like middlewares that, for example, send some data out to the network or write a file to disk or that kind of thing. So that's happening on the server. The client doesn't need to know about it. You can sort of ignore it. And the other thing is when we get an action that is tagged, because it's come from the client, we basically will send that action. So we'll send the action out to the clients unless it's tagged. So when an action is running through Redux, if it came from a client, we don't need to send it back again because you'll end up in this sort of infinite loop. It'll be a bit of a mess. I hope that's making some sense. I have some code available on GitHub, which you can have a look at. I'll put a link up to that later. But yeah, let's look at one more little kind of trick that we can do. Okay, so the new bit is on the right. So now imagine that you have a middleware that's dispatching loads more actions. So you said, okay, I've run a thing, a middleware's gone, okay, I've seen that action, and actually because of that, I want a whole bunch of other things to happen. It'll just keep dispatching more and more and more actions on that Redux state, and all of that will essentially happen in kind of one tick in JavaScript, right? So we could send each of those actions up individually up to the browser, but then the browser's going to have to go, okay, I got that action, going to re-render. Got another action, going to re-render. Got another action, going to re-render. But we know basically if they're all happening in the same kind of like Redux kind of loop, like JavaScript loop, we can basically batch them all up and just send them in a batch, apply them all in one go, and then do one re-render. I did have some code for this, but to be honest, it's a bit boring to look at, so I just thought I'll just skip it. So yeah, so basically, let's see if we can make this work. So I'm going to do a demo. I will flash up a URL in a moment. The rules are you have one chance to press the button. The lowest score wins. And if nobody presses, the counter will reset back to a high number. Okay. This is, if you've ever played the button on Reddit as one of their April Fool's things like many years ago, it's based on that. But yeah, anyway, there you go. Let's see how we do. I feel like I should get it up on the screen. Let me have a look. There we go. Oh, we have a winner. We've got 12. Can anyone beat 12? Oh, come on. Come on.
You didn't say the button gets smaller.
Oh, well, if someone's editing the button, I can't do anything about it. If you open settings, you can mess around with the button. Still 12, still the winner. Oh, 7. Very nice. Very nice. All right, I'll leave it up for a couple more minutes. Oh, you let it go. Oh, no. Can we beat 7? Go on. Oh, they made it really small. Oh. Someone's going mad on the colors. This is great. I should probably set a minimum size on the button, otherwise this gets a bit harder, doesn't it?
I thought that was
Nice.
Hang on, no one got that one.
No, so if it goes down to 0, it's going to reset, and then the number gets bigger, and it gets harder for everyone. Okay, I'll leave it one more minute. I love it. Go on. So yeah, so all the cursor positions are just stored in a Redux slice. When you click the button, that's stored in a Redux slice. And there's just something running on the server that's just telling it to tick down, which is, again, a Redux action. So everyone's just getting that same Redux action happening at the same time. Oh, come on. Oh, no, you missed it again. All right, okay, we're moving on, we're moving on. That was sneaky. Right, I think everyone's probably still looking at their phones now, but anyway, we'll carry on. So yeah, so basically, does it work? You've seen it work in a little app, but did it work in COGS? Well, we kind of released a kind of point release update where we completely re-architected how all this stuff works, including changing a whole bunch of the UI code. So there were a few things we had to tweak and a few other bits that I might come to later if we want to talk about it. But nobody noticed. So we just went from 4.12 to 4.13 and nobody noticed there was any difference. So I think that was a pretty good sign that it worked. We just said performance improvements in the release notes, and they were. It was great, and we could deal with bigger and more complex productions, and it worked really, really well. And then in version 5, which we released a few months ago, we basically said, right, we're going to officially make this whole new thing a feature called remote access. So basically what that does is it just shows you what port it's running on and gives you a URL that you can copy and paste to anyone else on your local network, and they can mess around with it. We added some authentication in so people don't just sort of, mess around with it willy-nilly when they're not supposed to. And then also we added an integration. Actually, we're using the ngrok SDK for this. So there's like a thing built into everybody's accounts where they can log into their account, and it will give them access to this over the internet with all password protected and everything. And so it means that they can control their COGS installation from anywhere. So, these people kind of running theater shows can say, well, I could be on the other side of the world, I could be on holiday, but I can go in and see exactly what's going on right now. And we're just adding more and more stuff to this. But yeah, and actually one of the cool things that came out of this as well is that we can kind of run the whole thing as like a sort of demo standalone web app. So if we kind of take out that enhancer, the thing that connects to a server, we just remove that bit. We don't worry about it. And then we have a preloaded state. So we just say, okay, here's the state that I want to appear in my demo. You pass that into your store, and you can just run it in a web browser, and you've got something that looks a bit like COGS. So that screenshot I had at the beginning was just from demo.cogs.show. So you can play around with that. It doesn't work very well on a phone because it's designed to be a kind of desktop app, but it's a good way of seeing how it works, and it's a good sort of learning tool. Yeah, so that's kind of the main stuff I got to talk about. There's like a whole bunch of other things that kind of came up, and I'll kind of run through them. If anyone has any, maybe like has any questions along the way, I'll gloss over them quickly, but if you want me to dive into them a bit more, just ask. So other things we had to think about, it's like people have different browsers. We're no longer just running in one version of Chrome, actually, and as a web developer, to be writing all of your stuff for one version of Chrome is like absolute bliss. It's incredible. But now we're like, oh, well, it could be using any version of Chrome. It could be using Firefox, and God forbid they use Safari. And we're like, oh, okay, right. Now we have to do a whole load more stuff just to make that work. So we found a whole bunch of APIs that weren't quite the same. To be fair, I think, standards have gotten a lot better. Standard compliance has gotten a lot better. So actually, most of it worked, but there were a few things we had to tweak. There are a few other things that we were kind of misusing Redux a little bit. So in Redux, you can kind of put anything into your store. So you can put any old object, anything you want. You could put the number infinity, which is great, but infinity is not JSON serializable. And we're using JSON as our serialization format to send stuff from server out of the browser. So anything that looks like that can't be serialized properly. And so we ended up having to sort of go through everything and go, hang on a minute, there are these things that can't be serialized. If you use Redux Toolkit, if this is a problem that you're kind of thinking about, they actually have a middleware that will check for you if you're doing this and kind of like warn you on the console when it happens. That's really helpful. So we had no direct access to files. We actually used to have some React code that in it would just say, like, actually just copy this file from here to here, because you could drag a file into the window and it would say, okay, fine, I'll just write that file into your project folder somewhere. You can't do that anymore. So instead we had to build it like a proper web app. So you'd have to do a proper file upload to the server. The server would get all that data and then go, okay, now I can write the file to the right place. Time synchronization, this was a fun one. So in the COGS user interface, as soon as you start something, there is a timer ticking down or ticking up, depending which way around you want it. So if you're on a different machine, it might have a slightly different time, especially with things like Raspberry Pis, if you're using that sort of thing. Raspberry Pis do time synchronization, but when they boot, they're actually, because they don't have any power on board, they'll boot with the time at whenever that image was created. So we have a whole bunch of stuff that every time it starts thinks it's 2022. I'm like, okay, this is really annoying. And it says, the time is like, I don't know, yeah, completely way off by many years. So actually we ended up having to build some time synchronization in. So we used something based on the NTP protocol. So it's network time protocol. It's the kind of old fashioned way of doing this. There are more modern ways of doing this, but it turns out there's a JavaScript library that kind of just does it for you. So we do that over that socket.io WebSocket, and it keeps things in sync within, on a local network within sort of like a couple of milliseconds, which is pretty great. So that's totally fine for all of our use cases. Sorry? It's just like NTP.js or something like that. Like if you just search for NTP on npm.js, it will come up. I mentioned uploading media files. That was one of those things we had to implement in a more kind of like standard client server way. We basically had to embody a web developer a lot more than we were, essentially, despite using a lot of web technologies. And this is something that we're looking at, which is like seeing other people's views. So just like you saw on that demo and you could see other people's mouse cursors, we want to be able to sort of say, can I just click on someone and see what they're seeing? So if you ever use Figma, it does this really, really well. Whimsical is actually a tool that we use a lot, which is really great. And that does a very similar thing. I think you can do it in Google Docs, but I'm not sure. But you can kind of just click on someone and then it will immediately switch to their view and you can kind of follow around what they're doing. And we kind of think this would be a really useful way to teach people about using the software and training and all that sort of stuff. But yeah, all of that stuff just works by, if you have your own, basically all the state about what you are seeing, if you store that in a Redux slice and you store the state of what everyone is seeing in a Redux slice, all you have to do is just say the ID of the connection that I want to display. You just switch it to a different ID and it'll go, okay, now I'll just show you what someone else is seeing rather than what you're seeing. It works really, really well. But yeah, that's kind of all I've got to say. I'm very happy to take questions and show you some stuff, but thanks very much for listening.
For a second, thanks so much. I'm just thinking, thank you so much for the talk, Chetan. I'm just realizing that I forgot to tell everyone that there are drinks in the fridge and drinks sort of there, and I'm just looking at it's rather Spartan there. So is it okay if we take a couple of minutes, quick sort of comfort break and refresh break, and then do you mind if we just pepper you with questions after that, Chetan? Okay, brilliant. Okay, very quick comfort break, people. We'll be back in a few minutes, yeah? Is now. Okay, welcome back. Thanks very much, folks. It is time for questions with Chetan. Fantastic talk. Who's got a question? Oh, look at that. That was rapid hands up, but I think Dom, you were first.
Sorry, I just wanted to ask, because you're synchronizing state between two separate processes.
Yes.
And how often does that go wrong? And what do you do about it?
Well, because it's all running over WebSockets, so running over TCP, as long as it's there is a connection, anything, if there's a flaky network, basically what socket IO is doing under the hood is just sending like a kind of ping message just backwards and forwards. If that fails, then it kind of comes back to you and says, hang on, we're disconnected. You need to do something about this. So basically we have a timeout set for like a few seconds essentially. So if something goes wrong, worst case is that you'll see that update locally, but that won't make it through to the server. And so that won't actually happen. So one thing that's kind of on my to-do list is to kind of tell you when that happens and go, hang on, we're disconnected now. And actually these few actions that came through didn't get through, because you probably need to know.
So if you were doing, if you're doing like a theatre show, you're right in the middle of it and it drops down, because you said it's local. So do they run your COGS from their actual local host, like have their own machine and run it through there?
That's a good question. So whenever we're like, for any kind of theatre shows and whatever, we're always running things over a local network. So it's as reliable as your, as the cables and your router.
Yeah.
Like we tend to not really run anything over Wi-Fi or anything like that. So we're just like, we know there's copper running between everything. So it's going to deal with it totally fine. Okay, cool. And generally it's only like, if you're remoting into it, you might do that over a cable, but you might do it over Wi-Fi. But actually, if it's just the user interface, then we don't really mind so much.
Okay, great.
Yeah, I had the same question about reliability, because I was wondering the same thing. Like what happens if the TCP connection drops, and then or like you were talking about like multiple clients having the same sort of view. So if you have like one client connected doing something, the other client connects 5 minutes later. So does it send over the entire state up to that point?
Yeah. So at the second it connects, so every time there's a connection established, the first thing it does is say, I'm going to send all of the state in its current form up to you, and we'll move from there. So so that's basically the main way we deal with disconnections. It's just you almost kind of reset entirely when a new connection's established.
Right. Okay. Yeah, that sort of makes sense. Yeah, that I could just restart it to get it back to a clean state.
Yeah.
I have a sort of slightly non-technical question, but it's technical.
Okay.
If you're working on it remotely, how do you visualize how do you visualize that? Do you have to have someone on site doing it, or can you do it? Can you use the software to make something that doesn't quite exist in hardware yet, or is it always? Does it always all have to be connected?
Yeah. So the way we've designed the software is so that you can kind of simulate anything that's hardware-y. So you can sort of say, okay, I have a switch. I'll put a switch in the project, but it's not connected to any hardware at the moment. So then you just get a little switch where you get like a kind of switch on the screen where you can kind of toggle it, so you can mess around with it. So you can kind of build up all the logic that you want, and then hopefully you just connect all your hardware up to it because you've made it, do what you want to do. You've even got sort of windows that you can pop open for things that will, play videos or, play audio and all that kind of stuff. Just, a window will pop open, you can make sure it does the right thing, and then you can connect it up to some hardware that will kind of display it in the right place.
Yeah, it was just, I think when we built something quite similar, not as complicated as yours, but for a specific show, and when we just opened multiple tabs in the browser, and each tab was a kind of device. So you could see all your kind of, you could switch between them all. Kind of multi-window sort of scenarios.
Yeah, it's sort of not far off how it really works, to be honest.
Yeah, cool, thanks.
I was wondering, like, what kind of hardware does this work with? Also, I was wondering a little bit about what kind of have you ever made like a self-contained, like a escape room in a box kind of solution with this system?
Good questions. So actually, now that so actually a lot of the CPU usage of like running COGS, day to day, was actually just rendering that UI. It's your browser kind of going, right, I need to work out what to render, put it in the right place, do all the CSS, apply any animations, all that kind of stuff. That's what it's spending 90% of its time doing. If you remove that bit, then it's super performant because all it's running is like a Redux loop that's just moving data around inside V8. There's no DOM kind of manipulation or whatever at all. So I was just showing everyone, this is running on a Raspberry Pi in my house and controls all the lights. And it's totally fine. Like, yeah, so it works great. So we built a Zigbee integration into it that has like light switches and all my lights. I've got like I've got something that controls the colors of the lights and the dimness and all that kind of stuff. Yeah, and it works great. So it's just, all it has to be able to do is start Electron. So start kind of, if it can run Chrome, you're good. That's it. That's all you need. What was the second question? Sorry, you did have two.
If you've made this into like a self-contained escape room in a box.
Yes.
I have a friend who's an escape room designer, and he's making these things at the moment.
So we have not, but there's a company based in Brighton called Peer Pressure who run a whole bunch of escape rooms, and they've actually started another arm of their business, kind of designing and building escape roomy type things for other people. They're actually using a lot of our hardware and software for that. Just for fun, they built a thing for a really, like in the escape room world, a very famous YouTuber called Chris Ramsey. So they basically built this kind of quite tall thing full of lots of COGS hardware, running COGS, I think on a Raspberry Pi, shipped it to Canada. And he did this whole video of him using all this stuff, and it was just running in this little thing. And it was amazing. So yeah, just if you search for that on YouTube, so if you search for Chris Ramsey, Peer Pressure probably is the best way to find it. Yeah, it was really good.
Peer like Brighton Beer, yeah.
Yes, not like peer pressure.
Yeah.
Yeah.
Okay, I think the next questions were down here.
Like when there's like a browser action that takes place.
Yeah.
Why does that get turned into a draft action, but like the client action just doesn't get turned into a draft action?
So the browser and the client are kind of the same thing, right? So so when we say client, I guess I meant browser at the same time. I probably interchanged those words, which was maybe a little bit confusing. So the server is like the machine running COGS, or like the process running COGS, because sometimes you'll just be looking at it on the same machine.
Yeah.
And then the draft action that's happening there is basically so that if I click a button here, I want to immediately see, like, if that button will like disable something, I want to see that that's happened immediately.
Yeah.
So I will see it immediately rather than having to wait for it to send that message like to my house and back, right? So instead I'll see that happen immediately, and then the server and COGS will kind of come back and say, hey, look, here is the action that you sent me, and here's the kind of like the real version of it. Now you can run that.
Oh, thank you.
Cool. I'm going to now, and then, or yeah, whenever. Okay.
I was wondering, do draft actions ever get rejected, and when would they ever get rejected? And what happens in the user interface as well?
Good question.
Yeah.
I can't think
or
of
have you not thought of this?
No, I mean, so I can't really think of a situation where that would happen, right? At any point in the Redux store. So the browser will always have a complete copy of that Redux store and all of the code for running all the reducers. So it can take one of those actions, it will run that action, and something will happen. Worst case, nothing will happen, but something will happen. And then it will send that to the server. It might be that you haven't yet had some of the other actions from the server, so it doesn't quite make sense.
So like two people editing the same thing.
Yes.
Okay. Gotcha.
Yeah, and so we do have some things that don't make sense in this model if you happen to do it at exactly the same time.
Right.
So So for example, like some of our Redux actions are just like update this whole thing, this massive giant data structure. So if that happens and someone else clicks something else, then they'll both send an update saying update this massive giant data structure, and whichever comes last will win because they're just sending all of that data over. So kind of what we're doing piecemeal is trying to reduce the size of those actions. So we kind of make more actions that are more specific so they're less likely to conflict.
That makes sense. Yeah.
If you're going to use it for like you say in your house, so mostly I can see here it's all about lights, but what about other things? So like smart homes, like, you know, open a garage or windows or, you know, electronic locks. Have you ever thought about adding stuff like that to your?
Yeah, so we're slowly adding more and more stuff, but kind of the way that we think about COGS is like it's a thing that can integrate with lots of other stuff. So, you know, with a lot of the smart home stuff, for example, like if you're running Home Assistant or you're running HomeKit or any of these things, they'll have some sort of like, a lot of them will be running like an HTTP server or something like that. And you can kind of just send a message out to that and you can get that to do whatever you want. So you can just kind of add the turn on the HTTP thing in here, get that to send a message out to it, and then it can kind of control it like that. So yeah, so all of that is kind of built into the core, which is all running in Redux, and then you can kind of just all edit it from here.
Go for it.
Just a kind of fun question, fantasy. But given all that with smart homes and that, and if you can create a show like template and send it to people at home, and they can, you know, have Saw at home kind of thing. Or
it's a great way to sell a lot more hardware, to be fair. Yeah, I think it's a great idea. And like we've had a few people kind of like one of the guys on our team made a version of Pac-Man that somehow he managed to implement like here with all the buttons in COGS. I don't really understand how he did it. Which is completely mad, but yeah, you can just open that sort of thing, and that one's just pure software. But anything that links to hardware, yeah, I mean, absolutely, you could do that, but you just need to have the hardware with you, you know, when you do it.
Can you tap into like Google Home that a lot of people have?
Yeah, I guess you could. I mean, it's all about, I guess, just adding the right integration, right? So if there's a particular API that Google Home has, you could say, okay, this thing is expecting a Google Home, just, you know, make sure you found it or you've got its IP address or whatever. And at that point, you'll be able to communicate with it.
I love the marketing of it, like ship your enemies Saw or Saw as a service. Tom, sorry, I'll come to you one sec, but I just going to have a brief monologue / soliloquy. I think this is a really interesting challenge that you've got here, because whereas most web apps, like 99% of web apps, are built with that sort of client server model where, yeah, you might get some network conditions and you just kind of have to deal with it. It's okay. You just can't have that in a performance. You know, this is something where you absolutely have to have everything running reliably, as you said. However, I think the thing that I'm wondering is, could you have two separate phases to this? So you have like a build phase, which could be done in the more traditional architecture of like client server, and you've got this running in AWS or GCP or whatever, and then you sort of wrap it up in a build, and that build belongs on one computer and runs an Electron and does everything as you've got. Like, is that something that you considered? What are the pros and cons of that?
Something I'd love to make, actually, and something we talked about. So if you could if you don't even need to install the software, you know, the whole thing runs in a browser now. So if you could do that in a browser, it's saving to an account somewhere. And at some point you can just install it, load it up and go, right, now connect all the hardware and you're good to go. And then go back and edit it, just, you know, edit that kind of like the source project.
Yeah.
I mean, that would be amazing. That, I think in terms of workflow, that'd be a lot better. Yeah, I'd love to build that, but.
Nice, COGS 6.
Yeah. Exactly. Yeah.
That's right.
Oh. I'm sure it was.
I'm sure it was very interesting, Tom.
Hello. Yeah, I missed the beginning, but I'm assuming from what you were saying that you were using full fat Redux instead of Redux Toolkit for the state management.
We started building this when Redux Toolkit didn't exist. So it's all, I know you say full fat Redux, but like Redux without Redux Toolkit is just very simple and very dumb. So we have a lot of very simple and very dumb code. The little demo that I built, actually, I built in Redux Toolkit. And to be honest, I hadn't used Redux Toolkit until 3 days ago when I started making that. And it's great. It's basically, it wraps up a whole load of like nice concepts, sort of things that we'd realized that we should be doing in Redux, and wraps it all up in a nice API, you know, and it's great. So yeah, if you're using Redux, I would recommend Redux Toolkit. In fact, the Redux team recommend you use Redux Toolkit.
Yeah, to see that. And because you mentioned about mutation of state as well. And I think one of the things in Redux Toolkit was that you could modify the state through the immer library or something like that, I think it was. That was one of the bigger changes, I think, in the library.
So, okay, so this is something that I'm actually really glad that we wrote some Redux code before having Redux Toolkit, because then you really understand why. So, so with Redux, you're always returning a copy of some state with something changed, rather than changing the state itself. Because if you change the state itself and you go, right, is this thing the same as that thing? The only way you can work out if something's changed is to basically do like a complete search of that entire object to see if something's changed. Whereas if you guarantee that every update has changed if it changes something somewhere, then you're going to end up with a copy and have a whole new thing. You can basically just do like a reference equality. Yeah, and then you know something's changed. So that's kind of one of the main reasons that Redux and React Redux is particularly efficient. And then after a while, we kind of were like, oh, immer, that thing's really cool. So immer, if you don't know, immer is a library. It means always in German. It's a sort of immutable state library. What it does is it gives you a function called produce that allows you to write code as if you're changing something, but under the hood, what it's doing is going, oh, you changed something. I'm going to make an entire copy of that and give you something new back. And I think if I hadn't have written Redux the old-fashioned way, I don't think I'd fully appreciate how useful that is and how much code that saves. So yeah.
And it kind of messes with that functional paradigm a bit, as in the in-out, not modification type idea. Thanks.
I guess it saves a lot of spreading. My mother-in-law is called Emma, by the way.
Oh, really?
Random aside. Does anyone else have a question? Niall.
Does this allow for real-time editing of the software as well? So say if there's a show ongoing, can you then be like, oh, I don't want it to work that way. I want it to work this way.
Oh, wow. Some like crazy meta-programming. Yes, yeah. I guess you could get it to rewrite itself. I mean, the way it works at the moment is everything is bundled up with Webpack as like an enormous JavaScript file. It's like 4 meg or something. It's quite big, right. But whatever. But that just gets loaded in once. That's what's running in the app. I guess you could like you could split it up into bits and update bits of it.
What happens if there's an invalid state when you edit as well?
How do you mean?
So say you edit something to then work another way, and then it's working in the old way. And that old way isn't supported by whatever the new way is doing.
Oh, I see. So you're saying like if the server's essentially running some different code at that point?
Yeah, essentially.
Yeah. That is a good question. If you look in fact, in the GitHub repo, I'll move back. There is an example in that GitHub repo of how to do it. It's really simple. Essentially, all I do is one of the slices inside Redux, I just store a unique ID. So I just make a UUID, just kind of randomly generated. And then every time the store is initiated, it ends up with a new unique ID, right? So all you have to do is on the client side is go, wait, that ID is not the one we had a minute ago. So something's restarted.
Okay.
And then you just refresh the page because that's the easiest way to deal with it.
That makes sense. Yeah.
No. Oh, okay, 1 second, Julian. Yeah. I'll be right there. Have you heard of / considered finite state machines, and would they be a good fit for this sort of thing?
Redux is a finite state machine in sort of a very straight line finite state machine.
Yeah, it is, but that's it. It's a very straight line. I'm just wondering if something like XState would would help in this paradigm. I just don't know nearly enough about it. But do you have instances where it's like, okay, well, when this thing is flashing, then it should be able to go to this state or that state or whatever? And sort of, is there a benefit to being able to sort of tightly constrain what state is? Like, for example, like you don't want to overload the power grid, for example, something like that. So
yeah, I think actually for the state of the entire application, Redux actually does that really well. Anything you're not looking at anymore just ends up being kind of garbage collected. You don't have to worry about it, and everything's just moving to that new state. And there's so many different parts of the app and so much complexity you could build in. Putting the whole thing into one finite state machine, I think, would be really difficult. But one thing that people struggle with a lot of the time is going like, okay, I have a sequence of things. I need to make sure that people press these buttons in this particular order and no other order. And if they get it wrong, it has to go back to the beginning. And for something like that, building a finite state machine kind of as one of those components, maybe in one of those little Redux slices would be ideal. But yeah, it's a good idea.
I'd recommend checking out XState for something like that, because I'm pretty sure you can tie it into Redux. So
cool.
So, yeah,
thanks.
Another slightly outre question, but I liked the illustration that you showed of yourself earlier, and I noticed your desktop had one as well. So at the end, maybe we could have a look at that if you minimize the COGS window.
Sure. Yeah. Yeah. No, like I said, I've got a very good illustrator, and we keep leaning on him for some really great stuff.
Nice.
Yeah. And I mean, we're not hiring, but if you did work for us, one of the perks is you get an illustration done of you, which is great.
Sweet. Anyone else got a question? I feel
yes.
Oh,
yes,
Charlie, and you contender enders.
I have many questions for you, Chetan.
Okay, go on.
The first one was, did I see something on your home settings that said bedroom disco?
Yes. Yes, you did.
Could you tell us a little bit about that?
It was just an experiment.
Have you seen Austin Powers?
There you go. So this is the behavior that controls the bedroom disco. What you can see, all it does is cycle through a load of colors. So it basically just says, change the uplighter color to this, to this, to this, to this, to this, and then just runs it around in a loop a bunch of times, and then just change it back to before. You can just sort of like turn on a sort of 5-second disco. It's a very short disco. But yeah, I was just messing around to see if it works, basically, but it's cool. Quite fun to have that button.
That's very cool. Could you control a whole show doing that with lights? Was the question.
Do a whole show doing that, using your thing,
yeah, absolutely.
Somebody being there.
So you could kind of like do it all remotely. Yeah, you could kind of set up all the buttons and things that you wanted. The only thing is, if you're not there physically, you don't know where people are. Right, some of the things that we've done before are like setting up camera feeds, right?
Yeah.
We haven't built it into any of this kind of like remote viewing stuff yet.
Right.
But if you could, on that main screen, kind of go, oh, I can see a camera, and I have a camera feed of where everyone is. Yeah. Then you could do that, and then also be like, okay, they're in the right place. I'm going to press the button and run the whole remote. So instead of pressing a button to swap, you could just do it on there, or say if you timed it to swap camera feeds. Yes, yeah. So you could do that. I mean, generally the sorts of things that people use this for are like sticking sensors everywhere. So you put a sensor somewhere, you know where someone is. They've placed an object in a particular place. They've walked through a particular area. A door was open. So you can actually, it's almost a lot easier to just add sensors everywhere and then just go, okay, I know what's going on. I know where they are.
That's cool. That sort of answers some of what I was going to ask you, because I'm very interested in like how, so like I'm a big music lover. Some of the best shows I've seen have like a huge, like the light show could be something which is so fantastic. It makes the show sort of an experience. I saw an amazing Bon Iver gig a year or two ago where there were kind of like mirrors being hung and moved throughout the show, and lights being shone and reflected off the mirrors. It was just fantastic show, made a real experience of the whole thing. We don't have time for how many questions I have for how you could use this to work with like a live show of that sort.
Yeah.
But I do want to ask you how, like, what has been kind of one of the biggest challenges of like a job that came in or a brief that came in that really made you and the team like scratch your head and work out how are we gonna approach this and how we're gonna like deliver what we want, but we've got some challenges that we've got to overcome in the way to get there.
That's a really good question. But first, I'm going to say that if you like a kind of amazing lighting show, ABBA Voyage is amazing.
Cool.
I mean, I'm not an ABBA fan, but like as a spectacle, it is incredible. I mean, yeah, I have so many thoughts. But anyway, but yeah, in terms of kind of like what's like something really interesting, I think because we work on kind of big things all over the place, inevitably they all end up coming back with something or other where they're like, we want this specific thing, we want this specific experience. And that's one of the fun things I think about working on like immersive theater and escape roomy type things, is that generally you don't get any two that are the same. And so it tends to be, and actually there's a big spread of different stuff, right? So sometimes they're like, we want this on a screen and then we want it to blend into this. Like we did this Doctor Who thing and they're like, we want a TARDIS flying by, but you know, it has to have another thing flying by, but they all have to be based on certain triggers and they all have to be kind of be able to like composite over the top of each other and all that kind of stuff. So we're like, okay, right, that's a whole load of like media stuff that we haven't done before, we had to think about. But then there's a lot more kind of hardware-y stuff, right? So I know like in Saw, there were a load of scales and then you had to weigh certain, I think you were weighing bits of sort of pig carcass that you would drag around and they were like hanging on these scales. So they would have to measure the scales and you have to get the number exactly right. So like working out how to integrate those scales with these things was like fascinating. And like these taps you have to turn on really fast, which is in the sort of like bloody bathroom. And you have to like turn them to exactly the right number of times to make this thing happen. So, but it varies a lot. And I think that's one of the things that makes working on this quite fun actually. It's just that everyone asks us for something different.
Yeah.
And the challenges are like sometimes hardware, sometimes software. Sometimes we have to like make a whole new bit of hardware, like custom circuit boards for the things that we're making, all sorts. So.
I have one more question, if it's cool. Has anything ever come across the desk that involves something where within the show that's like basically like improvised, where like you can't be totally sure what's going to happen, but you still want a reaction when a certain something happens?
Yeah. And that happens actually quite a lot. So a lot of immersive theater type shows and actually all the good escape rooms and things like that will have an actor there, right? There'll be like someone will kind of be there in character, in costume, leading you into something. Because if you don't have that, it doesn't feel quite as immersive as it could have done. And so their job is essentially to kind of like riff off and react off the audience that's there. So, you know, especially on the bigger shows, like a lot of the things that we're building in is sort of like manual overrides or manual triggers for lots of stuff. So like we worked on Monopoly Life Sized in London, which is like on Tottenham Court Road. And it's like this 4 huge kind of Monopoly boards about the size of this entire room. And on each square is essentially a room with a game in it. And a lot of that is like, you know, each one like is running its own kind of separate game or escape room or something. Yeah, and they get pretty complicated. Sorry, what was the original question? I just lost my train of thought.
Improvisation, stuff that you can't plan
Okay, so they
for,
get pretty
I
complicated,
guess.
but then, you know, they have someone who is your like player piece, right? So there'll be someone like dressed as a little dog who's kind of following you around, right? And they're kind of like riffing off you and being like, are you ready? Whatever. So what we're doing is like, we're either building a custom interface on an iPad and going like, here are all the buttons that you need, or we'll just put a big giant red button in the room so they can hit that if something goes wrong or they need to start something or whatever. So yeah, we kind of build that into the design kind of early on as just like another interaction thing, but it's just designed for the staff to use.
Awesome. Cool. Anyone else?
Very cool. I think poor Chetan has had to put up with quite a few questions.
Well, thank you for asking them.
Charlie, you get as many questions as you like because you've been so supportive over the last few months. So yeah, but everyone else, I think we're okay. Okay, fantastic. It's time for closing remarks. I thought of nothing. But thankfully I don't need to think of anything because I just want to say a huge round of applause and thanks for Chetan. Thank you so much. Okay, so I have thought of a closing remark. Next month, we don't know what we're doing. So if anyone has any ideas, if anyone has any talks that have been brewing in their back of their minds, please come and talk to me afterwards. I would love to hear some ideas. If not, don't worry, we'll come up with something like we always do. But it would be lovely to get any thoughts, like crowdsource some ideas. Aside from anything else, maybe we could try and do a Saw live experience for Async. I don't know.
Yeah, the original one's closed, so we'd have to recreate it for you.
Yeah. I guess that's probably yeah.
But you could go and play the Paddington themed room that Stuart's been working on with us actually. Which if you have children, I would recommend. But if you don't have children,
Fantastic.
maybe not so much. In fact, I don't know if they'd let you in. I'm not sure.
I have a 2-year-old, and you wouldn't want her anywhere near that, I promise. But anyway, so yes, next month we're not quite sure yet. Come and talk to us. The month after we do know. I've just forgotten. I'm sorry about that, but I'll let you know. So I just want to say a big thanks, firstly to Chetan, also to Silicon Brighton for providing all of the things. And a huge thanks to Runway East for providing the space that we are all in, as well as the pieces as well. Someone I didn't thank earlier as well was Jake, sitting there quietly over there, who is the backstop, who does all of the communications. I do nothing. It all happens between all of these other people that I'm thanking. So yeah, huge appreciation. We are going to stop now. We're going to clean up. If you could put your sort of bottles and cans on the table over there, we'll figure out what to do with it. And we're going to head round to Unbarred, which if you head out the door, turn right, and first right, it's at the end of the road on the left there. So yeah, all that remains is for me to ask you to put your hands together for a huge round of applause for Chetan. Thank you so much.